What's going on, guys? Welcome back to this video. Today we'll be doing a TryHackMe video, and I found while I was looking at the current available learning paths after we completed Intro to Cybersecurity and Pre-Security, I noticed that in the past I have nearly completed the Junior Penetration Pathway, but I figured there was some rooms that I haven't completed. So basically, on the side, if you want to view all of the videos related to this path, you can check out this playlist. I'm gonna put the link in the video description. You can see the solutions to all of the rooms under the Junior Pentester pathway. All right, now let's go here and find what are the rooms that I haven't touched. So basically, beside protocols and servers, part 1 and part 2, I noticed that the Nmap rooms are the rooms that I haven't covered in the past. So I said, why not make a video to cover these rooms, since Nmap is a very popular tool to conduct information gathering and scanning. So let's cover these 4 rooms. So I'm gonna cover the rooms in a different approach. Instead of going through the readings and everyone can read, but I'm going to skip directly to the commands that are used to explain every concept. So here I'm using the TryHackMe attack box, and the first type of scan that we're going to cover is the TCP connect scan. So basically, you can conduct TCP connect scan with the following command. Make sure before running Nmap that you have sudo privileges, or you have a user that can run commands as sudo. Now, TCP connect scan doesn't need elevated privileges, and it's worth noting that the TCP connect scan is the only type of scan in Nmap that's available under low privileges. So you can conduct -st without needing to be root or any other privilege user. Anyway, so Nmap -st, and then we put in the IP address of the host. This will conduct a TCP connect scan, meaning that we will send a TCP 3-way handshake, and depending on the response of the host, we will determine what are the open ports. That's how Nmap works when we use TCP connect scan. Now, TCP connect scan is a normal scan. It's not a stealthy scan, and it is a scan that is visible to system administrators and firewalls and network intrusion detection systems. As you can see, we discovered these open ports. Note that we have the ports that are open, the state, and we have the service running on the port. We don't have yet information about this version and other fingerprinting information about each service. If you have watched my videos on while we solve machines and CTFs, you may notice that we use -sv to discover the version of every service. Now, I'm not going to confuse you guys. So basically, that's the first type of scan that we do to conduct a TCP connect scan and discover the open ports. Now, there are a couple of questions. Let's answer them regarding this type of scan. So if you go here and we go to task 4, so the questions are: after we launch, a new service has been installed on this VM. Since our last scan, which port number was closed in the scan above but is now open on this target machine? So basically, the answer is IMAP, because the port is actually 110. It was closed on a previous scan in another room. And the answer to the other question, what's Nmap guess about the new installed service? It is POP3, as you can see. All right, now let's jump to the other type of scan. So I need first to terminate this machine, and here we need to launch this machine. All right, so the other type of scan is the stealth scan. Okay, so basically, let's talk a bit about the stealth scan while the machine IP pops up. So basically, the stealth scan, first it requires root privileges. As you can see, I'm not executing the scan with sudo because I'm already root on the machine. So make sure to when you want to conduct stealth scan is to use the sudo with the other user you are currently assigned to. So the other thing is that stealth scan doesn't complete the TCP 3-way handshake. So basically, once it receives a certain response from the server, it tears down the connection, it ends the connection. That's the hallmark of the TCP connect scan. It's the actual opposite of the TCP connect scan. In TCP connect scan, we complete the TCP 3-way handshake, synchronization, acknowledgement, and then sync acknowledgement. But here we send synchronization packet from the our machine. We receive acknowledgement from the host that the port is open, and then we send a reset packet to the machine, ending the connection. So once we receive a synchronization acknowledgement from the machine, it means that the port is open. Let's see if the IP is ready. No, yeah, the IP is ready. Let's conduct a scan. Now sometimes there is an anecdote that the self-scan is useful if you want to evade firewalls. Sometimes it might work against stateless firewalls, but if the firewall is stateful, it just doesn't work. Now let's see, we have these open ports, and still again, as you can see, the output is kind of similar, except the fact that we have a new open port, IRC protocol, and that's the question that we will have to answer here. What's the new open port? It is this. And what's the protocol? It's IRC. Okay, now let's now jump to the other type of scan, which is the UDP scan. We have to terminate this machine and launch the other machine. Alright, so TCP the UDP scan. Let's go here and find the available flags. So UDP scan can be conducted using -S uppercase U. And to help the scan, you can execute -F as well to make the scan faster. Now, what's the difference between a UDP scan and a TCP scan? Basically, in UDP scan, it's very difficult to know the status of the port, because UDP is a connectionless protocol, and therefore we don't expect a response from the server or from the target machine on the status or regarding the status of the port, whether it's open or not. But if the port is closed and you have issued a UDP scan, in that case, to know if the port is closed or open, the machine will give you an ICMP port unreachable if the port is closed. So that's the hallmark of a UDP scan. UDP scan, if the port is closed, it's going to give you ICMP port unreachable. But if the port is open or is filtered by the firewall, Nmap just cannot find out. Let's see here. This is the IP, and there we go. Okay. So the questions: launch the VM. A series service has been installed since the last scan. What's the UDP port that's now open? As you can see, if we suspect that there are UDP ports running on the machine or UDP services that rely on UDP protocol, we need to launch UDP scan to figure out or to find these open ports. Now, sometimes you don't, because basically if you scanned for all ports, eventually you will reach this port. Let's see if the scan is finished. Not finished yet. Okay, what's the service name according to Nmap? As you can see, we'll find that 53 is a new open port because it technically is a UDP port, and the new service is domain, meaning that a DNS server running on the machine. Okay. Now, if I go back here to the list of notes, I have categorized or organized the type of scans and the purpose of every scan in my notes. If you have subscribed to the channel membership, you have already got access to these notes. These notes are part of the Google Drive notes, not the online portal, by the way, for subscribers or for those who have subscribed. Now, as you can see here in this section, I mentioned UDP scan somewhere. Let's see. Yeah, UDP scan. So as you can see in UDP scan, we also control the timing. I'm going to talk about the timing later. But basically, guys, there are some things we have to put in mind. The first thing is, let's see, scroll down, some other general notes. Yeah, so what about -T? We see sometimes we use -T in scans. -T is used to control the speed of the scan. Okay, so 0 being the slowest and 5 being the fastest. So slowest, 0 and 1, so 0 and 1, parallel and sneaky, actually are used to evade IDAS and firewalls, because the scan will be very slow. The interval, there will be a huge interval between every packet that's sent to the ports, like 5 minutes between every port. So if you are scanning for like 100 ports, multiply 100 by 5, and you will have 500 minutes needed to finish the scan. That's why it's very useful if you want to evade firewalls and if you have time. Now T5 and T4 are the fastest, and they are the most aggressive and the most noisy. Don't use them if you want to evade firewalls or IDSs. Now, if you want an alternative for the timing, you can use something called the minimum rate. So basically here we control the rate of the packets. For example, you can specify a number of packets using -- minimum -rate, or a number of packets or a maximum number of packets to specify -- max -rate. For example, as you can see, -- max -rate 10 ensure that the scanner doesn't send more than 10 packets per second. Okay. Now you can use this one or this one for the evasion of firewall. I have also talked about firewall evasion in a separate section and the techniques used to evade firewalls. Alright, let's get back here. See if the scan is finished. It's finished. Let's go over the scan. As you can see, the output kind of differs from the output we received when we conducted TCP scan. So as you can see, we now have a new state, filtered and open. So here Nmap doesn't know the actual real status of the port, whether it's open, whether it's filtered. Why? Because UDP is a connectionless scan. So unless Nmap receives a response other than ICMP port unreachable, it cannot determine. So basically here on this scan it hasn't received a response. Here also it hasn't received a response, open and open. But when you see this one, it means that Nmap couldn't determine the response from the server because it's a connectionless scan. Now when you see a closed port here, it means that the Nmap received ICMP port unreachable. So if Nmap doesn't receive ICMP port unreachable, it means the port is either open or filtered, depending on the presence of firewall. Now this is regarding this room. Let's end the machine, save up resources, and move up to the next one. Port scans, advanced port scans. Let's launch the other machine. Alright, so here we will talk about the null scan, the finalized scan, and the XMAS scan. So let's see how we can use them. So Nmap-sn, that's how we use null scan, and it is called null scan because all the flags are set to 0. The TCP flags, the synchronization, acknowledgement, reset, push, all of these flags are set to 0 by Nmap. That's why it's called the null scan. And then we specify the IP address of the port. So basically a TCP packet with no flags, right, will not trigger any response when it reaches an open port. So basically, same as UDP scan or similar to UDP scan, the response from the server will be like nothing. It won't trigger any response because the flags are set to 0. The flags needed to complete the TCP three-way handshake are here set to 0. That's why it won't trigger any response when it reaches an open port. So what does that mean? It means that when we don't receive a response from the server, it means the port is either open or filtered because of the firewall. Now what happens when the port is closed? Nmap receives reset packet from the host. The IP is here. You don't need to memorize these details, right? But it's essential and tremendously beneficial to understand how the three-way handshake works for every scan and what are the flags set for every kind of scan. So again, in case of null scan, we send the flags. We set 0 is set to all the flags, and if the port is open, what's going to happen? Nmap won't receive a response. If the port is closed, the server will send a reset packet to Nmap. That's how Nmap will determine whether the port is open or closed. Now, also additional note that similar to UDP scan, if Nmap doesn't receive a response, it means that the port is either open or filtered, depending on the firewall. So in that case here, looks like there was a firewall blocking this port on port 68, but these ports were not blocked. Now another type of scan let's launch a new tab, not to waste time. And here, zoom in, zoom in, zoom in. So the other type of scan here is the finalized scan, or -SF. So Nmap -SF. So similar to the null scan, no response will be sent from the server if the port is open. It's the same as null scan. If the port is closed, the server or the machine or the target machine will send you a reset packet, meaning that the port is closed. Is the scan finished before launching the other scan? No. Okay, this one is finished. Let's launch the other one. Alright, let's go over the results. As you can see, we get something similar to the above. Open, filtered, open, filtered, open, filtered. It means that on these ports, Nmap has not received any or has not triggered any response from the server on these ports. The server didn't answer when the Nmap probed for these ports. That's why Nmap determined that these ports are definitely not closed. They might be open or they might be filtered. But most probably when you see this, means that there is firewall blocking these ports. Now the finalized scan, most probably will get results similar or output similar to the null scan. Open new tab and we will start the XMAS scan now. I'm going to tell you guys what is the purpose of these scans. Okay, so Nmap -SX. So the XMAS scan or the Christmas tree lights scan, it actually sets the find, the push, and the urge flag simultaneously. That's what happens. So 3 flags are set here to in the XMAS scan, not the null or not the finalized scan. So similarly here, guys, when the port is open, we will not receive any response from the server. But when the port is closed, we can receive reset packets. Alright, let's see here. Yeah, this one is finished. As you can see, results similar between the fin scan and the null scan. Let's test out the XMAS scan. So paste and run. Now when we will use these 3 kinds of scan, the finalize, the null, and the XMAS, do we use them to evade firewall? Of course not, because technically here we are not evading firewall. As you can see, these ports appear as filtered. So why do we use them? We use them to figure out the firewall rules. So we want to find out if there is a firewall in place, what are the rule sets of the firewalls. We launch these scans. We try to probe if we get some sort of filtered in here. It means if we get filtered on the ports, it means there might be some firewall in place, which will help us craft our scanning strategy. It means that we have to evade firewalls if we want to get more information about every certain service here. That's why we use them. Hopefully this will finish faster. Alright, now let's go to the questions. In a null scan, how many flags are set to 1? None. All of the flags are set to 0. In fin scan, we have 1 flag, and in the XMAS scan, we have 3. Once both are ready, open the terminal and attack box and use Nmap to launch a fin scan against the target. How many open ports or how many ports appear as open filtered? We will discover this. 1, 2, 3, 4, 5, 6, 7. Repeat scan, launching a null scan against the target. How many ports? Okay, let's see. 1, 2, 3, 4, 5, 6, 7. So we have indeed 7 ports. Now I don't think we need to wait for the fin scan to finish, and indeed finished. As you can see, same results. 1, 2, 3, 4, 5, 6, 7. 7 ports appear as open filtered. So nearly the same output we get by launching these 3 scans. So let's now talk about other two kinds of scan, the window and acknowledgement scan. So similar to these scans, the XMAS, the fin, and the null scan, the acknowledgement and the window scan can also be used to determine the firewall rule sets, or if there is firewall. So basically, let's take an example. So we have the machine opened, and we perform SA for acknowledgement scan. Acknowledgement scan sends an acknowledgement packet with an acknowledgement flag. So this means that this packet is kind of missing. For that reason, the server will respond with a reset flag, regardless of the state of the port. So if the port is open, closed, or filtered, or unfiltered, it's gonna send you a reset packet. So there is no way to know the status of the port here. It is just to learn if there is firewall. So what you can do here, you can launch the scan and learn the status of the ports. Similarly, with the Windows scan, it's the same, but in the Windows scan, we get to know we get to examine the TCP window field of the reset packet returned by the server. Now this, sometimes it reveals whether the port is open or not. Let's see here. Let's go back to acknowledgement scan. Look at this, unfiltered. So unfiltered, what does that mean? It means it could be either open or closed, right? We haven't determined the status of the port, right? We just determined that if there is what kind of firewall rule set in here. So it means that the firewall doesn't block these ports. So it might be safe to proceed and scan these ports specifically and be aggressive somehow using the version detection or OS detection as well. But if they appeared as filtered, it would have been much beneficial to start further scans with firewall evasion in mind. Now the same we can do with the Windows scan. So -w in this case. Now the difference here, as I told you guys, is in Windows scan we will be able to examine the window field, and examining the window fields in some systems can reveal if the port is open. Okay, let's take a look here. So we have these ports closed. So Nmap was successfully able to determine the status of the port by virtue of the window field. So basically Nmap received a reset packet from the host, that's true, but upon further inspection of the window field, it was able to determine that these ports are closed and yet not blocked by the firewall as well. Okay, answering the questions now. Which task we are at? This one. In a TCP window scan, how many flags are set? It's one, the acknowledgement. You decided to experiment with a custom TCP scan that has this reset flag set. What would you add after this? --scan -flags. Okay, we're going to talk about this. Now, next, use Nmap to launch an acknowledgement scan against the target VM. How many ports appear as unfiltered? So we have 4. What's the new port number that appeared? It's 443. And is there any service behind the newly discovered port? You might be saying yes, it is. But if you examine it with the browser, you're not going to find anything. So the answer is no. Okay. Let's terminate this machine. Do we have other machines to launch? No. We're going to talk about firewall evasion now for the rest of the tasks. Alright, now firewall evasion. So with firewall evasion, we have multiple options. The first one is to use stealth scan, but make sure to use the timing. So -T1 and -F fragmentation. We're going to talk in details about fragmentation, but for now, you can use a couple of these techniques. Stealth scan, okay, and then you're going to use T1 for a sneaky scan. It means it's going to wait like average between 3 to 5 minutes between every port. So you can use the scan maybe if you have time to wait for the scan to finish, or if you have a few number of ports. -F fragmentation. Fragmentation is the technique used by Nmap to fragment the TCP header into multiple bytes. Wherever TCP header is 24 bytes, right? So it will fragment the TCP header maybe to a number of packets, where every packet contains around 8 bytes or 4 bytes. That's the first technique. Unfortunately, we don't have a way to test this because in the current rules they don't have firewall implemented, so there is no way to find out if this is successful or not. But these are techniques that I attempted and tried by myself. The other way is to perform a decoy scan. Decoy scan is the ability or technique where you use a pool of IP addresses and you make them and you make them appear as the IPs that perform the scanning. This means on the target machine or in the logs or any other place, the administrator of the machine will see that these IP addresses 1, 2, 3 have performed the scan, not only your IP address. It's a beneficial way to obfuscate or to distract the administrator from the real IP that has performed the scan. But you have to include your IP address in the scan, and you can control the order. For example, you can use IP1, any IP you want. It will be the first IP that scanned the host. Then IP2 is the second IP that scanned the host, and lastly, this is your IP address. You can put your IP first or next, or you can put as many IP addresses as you want, and use -d option. If you don't have an IP address in mind that you want to use, you can use the RND or random. Random will generate IP addresses for you. Look at this one. -d, this is a given IP address, another given IP address, and then we use RND. To tell Nmap, you can generate IP addresses and put them as the IPs that have performed the scan. Again, we have our IP at the end. That's a decoy scan. It's very popular to evade firewalls, especially that if your IP is blocked or somehow has been added to a blacklist. But it's actually kind of more meaningful if you use the scan maybe to obfuscate your identity. You don't want to be tracked, so you use multiple IP addresses. Other technique that's used to spoof or to evade firewalls and IDSs is the spoof to scan. So in spoof to scan, we pick up an IP address for a machine that we are aware of or we have a visibility over, like in the network. And this is the command. So what happens here, we switch the interface, -pm, we disable the ping, and -s, and then the spoofed IP address. For this scan to be successful, since we don't have control over this IP address, we're not going to be able to determine there will be no output. Why? Because the machine will send the response of the TCP flags to this IP address, not your IP. So we will not be able to collect the output. You will have to have a sniffer running, right, on this interface, and then Nmap will be able to tell you the status of the ports based on the communication or based on the packets exchange between the target IP and the spoofed IP address. So if you don't have visibility, or if you are not on the same network of this IP address, like the same Wi-Fi or the same corporate network, it's not gonna be successful. Fragmented scan. In the fragmented scan, I said earlier, guys, we fragment the IP data or the TCP header into 8 bytes or less. So we use -f to perform fragmentation of the IP packet, specifically the TCP header. If we use -ff, what's going to happen, as you can see, instead of splitting the data into 8 bytes, it will split them into 16-byte fragments. Instead of -ff or -f, you can use -mtu to specify the minimum transmission unit. If you don't want to bother with details, just use -f or -ff to perform fragmentation. Now, this is another technique I have used in the past to change the user agent. So basically here, what I did, -sv to perform version detection, and --script-arguments. Here, I use a specific user agent to perform the scan, to fool the firewall. Again, another method to evade firewall is to control the timing. For me, controlling the timing is the most important piece here, because IDSs and firewalls rely on the intervals between every packet sent by the source to determine if it is kind of suspicious or not. So that's basic. Try to choose T1, or at max you can choose T2. And then you can pick up one of the techniques, like you can choose to fragment the scans, or you can choose to have a decoy. Alright, let's answer the questions. There is no machine here, so I'm gonna skip to the questions. So what do you need to add to the command to make the scan appear as if coming from the source IP address? Spoof scan. What do you need to add to the command to make the scan appear as if coming from the source IP addresses? Here we use decoy scan. More than one IP address, it's decoy scan. One IP address, it is actually a spoofed scan, because a decoy scan has to have more than one IP address, at least your IP and the other IP you want to use as a decoy. Fragmented packets. If a TCP segment has a size of 64 and we use -ff option, how many IP fragments will you get? Okay, so -ff will split the packets based on 16 bytes. So we divide 64 over 16. So basically, if we divide 64 here over 16, we will have 4. Which means that we will have 4 packets or 4 IP fragments. That's the number of IP fragments, okay, not their size. Zone P idle scan still usable to evade firewalls, but I don't believe you can use it in real scenario because it needs you to have access to a machine. First, you have to get access to a machine that's not usable or idle, like a printer. It's not reliable. Getting more details, dash reason. Okay, now that's for this one. Let's now go to the last room, which is post port scan. Alright, so in post port scan, we will determine what are the other details we want to gather from the host beside the status of the ports. So up until now, we talked about the different techniques used to extract the status of the ports and what can we use to evade firewalls. Now let's talk about other things that matter when we issue an Nmap scan. The other thing is the server detection. So let's launch the machine and take an example here. So these are not needed anymore. We're going to close them. Going to clear this, and here we're going to start the version scanning. So Nmap -sv. So here we say to Nmap that we need to perform an Nmap scan and detect the version and grab the banner of every service detected on every open port. Now -sv doesn't work with with the stealth scan -ss. Okay, so make sure to put that in mind. Let's see here. Okay, it's gonna take some time. So that's the switch we usually use when we conduct an Nmap scan on a machine that doesn't have firewall, or we know it doesn't have firewall. Now, does that mean that -sv cannot be used with firewalls? Of course, you can use it. You can use it to evade firewalls, but you have to add other switches, like the timing, like -t1, for example, and -f. Okay, at least because -sv, the version detection here, in order to grab the banner and the version of every service, Nmap will need to perform the TCP three-way handshake to complete the connection. Otherwise, it's not going to be able to grab the banner and determine the version. That's why this type of scan doesn't work with the stealth scan, because stealth scan doesn't complete the three-way handshake. So meaning you cannot do -sv-ss. It doesn't work. Alright, let's put the IP and see what kind of services we have along with their version. Now in a separate tab, we can talk about OS detection. So Nmap-O to perform OS detection. Basically, Nmap relies on fingerprinting attributes and characteristics of the output to determine the operating system. These are the results. These are the status of the port, the protocol, the service, and the version. Now, the version and the banner are beneficial if you want to find out if the said version is vulnerable or if it has a CVE publicly available, and if there is a matching exploit for that. Very beneficial for pen testing. That's it. Questions? What's the detected version for port 143? It is Dovecot IMAP. And which service did not have version detection? It is RPC point. No, it has. Why? Oh, okay, that's why. Because dash version dash light here, it's kind of controls. It doesn't control. It's the lighter version of version detection. You can control the intensity of the version detection, by the way, as you can see, using dash version dash light with intensity of 2, and dash dash version dash intensity, you can put 9 for the highest intensity. This controls the aggressiveness of the scan and how many details, how aggressive you want to go to grab the details. OS detection, finished? Not finished. Yeah, finished. As you can see with dash O, we'll be able to grab the details of the OS. Now, this is not necessarily true. It's just an estimation. So you can use it in your earlier stages of the pen test, but it doesn't necessarily mean that this OS has this exact same version. The version might differ. Alright, now up to the scripting engine, the most fun part. Let's turn on the machine of this task and skip to the questions. Now let's talk about the scripting engine. So Nmap scripting engine enables you to use Nmap Lua scripts or scripts created in Lua language to extend the functionality of your scan. Meaning, with Nmap scripting engine, we can perform brute force, we can perform discover, we can perform DOS attack, we can perform exploitation, we can perform fuzzing, so on and so forth. We can turn Nmap into a vulnerability scanner tool like Acunetics or Nessus or OWASP. We're not nearly as these, but it can have a bit like of functionality for them. So Nmap, or all of the scripts that Nmap or uses actually, they are under cd user share and then Nmap, I guess, script, yeah, ls, and we have all the scripts as you can see here. If you want to use a specific script in your scan, you have to put the name of the script. Now you have three options. We can either use the default option, this one, nmap dash dash script equal default. This will use the default category of the scan, like it will conduct discovery, exploit, external fuzzing on the target. If you don't specify a name, why it's not working here? Okay. And let's have the IP. So you run Nmap scan using the default option in the scripting engine, meaning we're going to use the default categories of the Nmap scripts. Alternatively, instead of this one, we can use dash sc. So dash sc. Yeah, here. As you can see, we have now more extensive results, more detailed output. So we have the port open, we have the service running, we have the version, and we have the SSH key. As you can see, we've got the SSH keys here. Again, we have here for the SMTP, we have more details. We grab the banner, the version, the domain, so on and so forth. Same for the other services. We can have now more details, and the details will differ depending on the protocol. The question is asking, knowing that Nmap scripts are saved under user share Nmap scripts on the attack box, what does the script check for? Alright, let's go over the scripts. So we're under the directory here. What we're going to do, we're going to say ls dash or ls grep robots. This will give us the name of the script. Now if we cat scrolling up, we will check the description to find out what it does. So here, up. Checks for disallowed entries. Can you figure out the name for the script? That checks for the remote code execution vulnerability. So given that Nmap names the scripts based on the protocol and the functionality, we're going to use this number, for example, to filter for this script, because the output will be so long if we just use ls grep and we use this number, and we have one result, and this is the name of the script. Launch the attack box. Okay, we already did this. You will notice that there is a service listening on port 53. What's its full version value? Port 53. Port 53. It's a DNS server running on the machine, and this is the complete version. Based on its description, the script SSH2 Nmap algos reports the number of algorithms that the target SSH2 server offers. What's the name of the key exchange algorithms that relies upon SSH1? Okay, this kind of requires you to specify a certain script to use. So nmap -- script and the script name here. So here it goes. And of course you're gonna need the IP address of the target. Launch. Finished. We need the key name of the key algorithm or key exchange algorithm. We have multiple algorithms here. We have key algorithms. We have the server host key algorithms. We have encryption algorithms. The ones that rely on SSH1 is only one, which is this one. And that's your answer. Now to the last task of this video, saving the output. So how do we save? Let's first end this machine and open up the other one and skip to the question. We're gonna answer the question after we explain. So saving the Nmap output. Saving the Nmap output, guys, is very important when you have multiple targets in a pen testing engagement, or you know that or you are aiming for a long output. So it doesn't look neat if you leave the output on the screen. I know I do it. I leave the output on the terminal without wrapping this in output file. I do that in CTFs, but it's just a CTF, right? So there are three types of Nmap outputs we can use. The first one is normal output. So Nmap, say -sv, then the IP address, and we use -on, and the file name. Say it is output.nmap. So here I saved the scan, okay, in a file named output.nmap. Now the normal file, it's just normal. There is nothing unique about it. The other beneficial one and useful one is the greppable format. The greppable format allows you to use grep and perform some filtering on the file. So you can do that using -o-g and output.g and then nmap. This is the other type of the output. This will enable you to use grep on the output. If you want to grep ports, grep protocols, grep versions, grep CVEs, grep IPs, you can use this one. I highly advise this one in real case scenarios or real engagements. And the last one, if you want to use the Nmap output on multiple programs, it's preferred if you use the XML format. -x and then you name the file. You can say Nmap XML. Okay, alright. Did we finish? Okay. The task here is different. Terminate the target machine. Okay, we did. Launch this command. Okay, to download the Nmap reports in normal and encryptable formats from the target machine. Let's do that. Yes. And we grab the password. So we have, as you can see, we downloaded two kinds of Nmap outputs. First one is normal and the other one is encryptable. Now it's up to you which one to use to answer the questions. Check the attached Nmap logs. How many systems are listening on the HTTPS port? How many systems are listening on this port? Okay, so what we can do, I'm going to use the encryptable format. So cat scan g nmap and then grep. What I want to do here, I want to extract, I want to find out the systems, I want to identify the systems that are listening on the port 443, the protocol HTTPS. So what I can do here, I can just use HTTPS, and this will give me three systems. One ends with 15, other one ends with 249, and the last one ends with 240. Three systems listening on port 443. What's the address of the system listening on port 8089? Same. Great for 8089, and this is the IP address. So that was it, guys. You got now the three or all the Nmap. I'm gonna add these videos to the current playlist of the Junior Penetration Tester Pathway, and we still have got the protocols and servers. I'm gonna make sure we go over this so that we wrap up this track. That was it, guys. I hope you enjoyed this, and I'm going to see you later.